What does it take to build a truly heavy-duty bucket? It starts with thick steel plates. Then come the heavy round reinforcement bars. A few hard blows set them in place. More structural steel is added from end to end. Piece by piece, the bucket begins to take shape. This is built for serious digging work. The bucket is basically the excavator's claw. Its main body is reinforced with alloy steel more than 1 centimeter thick. First, a CNC machine cuts the plates to size. These are the side plate reinforcements. They are already nearly 2 centimeters thick, but the next plate is even heavier. This is the core steel for the bucket. The freshly cut plates are then moved over and aligned against a larger base plate. Thicker steel makes the bucket stronger. But not every part of the bucket needs the same amount of steel. Take this section. The side plate does not take the hardest impact. Its main job is to hold the material inside the bucket. So here, I-beam steel is cut into smaller plates. Unlike the flat plates, this piece has a raised rib down the center. It is placed on the side plate, right down the middle. Besides these main parts, this bucket also gets smaller vertical ribs. A torch is used to cut each one to about 10 centimeters. For one side plate, about 6 of these small ribs are needed. Their placement is not random. First, 4 round bars are set in position. Then the small plates are fitted against them. This is how all 6 ribs are mounted on the side plate. They give the bucket better side strength during digging. In fact, every one of these plates is positioned according to the design. The purpose is simple. This custom layout can make the bucket stronger than stock. In some areas, you may see parts that look unusual. This bracket will connect to the excavator arm. It is being installed now. The shop uses high tensile steel frames here. These parts build up the base plate and add serious reinforcement. For the crew, this may be the longest stage of the job. When the schedule is tight, every available hand has to help keep the work moving. The second plate, over 3 centimeters thick, is the largest. It supports the bucket's tooth adapters. That extra size has a purpose. It helps absorb impact during excavation. Even in mine work, rocks are less likely to damage the teeth. A bucket only uses a limited number of adapters. On this one, there are about 5. The adapter is where each tooth is mounted. These adapters are normally welded permanently. Once the bucket leaves the shop, they stay fixed in place. Only the teeth are replaceable. The area where the tooth meets the adapter forms the tooth assembly. Next, the workers hoist the side plate into position. Both sides of the bucket are designed symmetrically. As long as the position is correct and the dimensions are within spec, it fits. This bucket is built for strength, not comfort. Now the arm linkage bracket is being installed. Once it reaches the center, the worker holding the guide chain starts adjusting it immediately. This work depends on coordination. One worker controls the position. Another tack welds it at exactly the right moment. Once the part stops shifting, it is secure enough. Then the crew can move on to the next step. The curved steel plate you see here was already rolled before installation. Its dimensions were measured in advance. No extra shaping is needed. The edges only need to be beveled, so the weld can penetrate properly. So where does this curved plate go? Let us watch the fit up. First, a magnetic lifter raises it off the ground. As it is moved forward, it is placed over the bucket bracket. The original bracket already has a base layer of steel. Even without this second layer, the bucket could still work. So why add it? Because it increases strength at the digging point. A standard bucket on a smaller excavator is usually much simpler. It is enough for normal daily work. But after heavy-duty reinforcement, the bucket weighs more and it can do harder work. That is why fabrication shops like this stay busy every day. Once the bucket is laid flat on the ground, the next fitting stage begins. This plate is much thinner than the earlier steel plates. From the side, it looks about 1 centimeter thick. But thickness is not the key point. The important part is how carefully it has to be installed. Compared with earlier steps, this is much harder. First, a grinder cleans the surface before the edges are tack welded. A full weld is not needed yet. It only has to hold its position. Then a marker is used to draw 2 vertical guidelines. These lines help the crew keep the fit accurate. In the shop, workers often leave extra material at first. Any extra can always be trimmed later. But if a plate is even a centimeter short, it may have to be scrapped. The steel sections being placed now act like bridges across the bucket. They line up with key load points across the front edge. Judging by their shape, they were likely cut from a main steel beam. The reinforcement method is simple, but it takes a coordinated 3-person team. 2 workers heat the steel with torches. As the steel gets hotter, another worker drives it down with a sledgehammer. The hard part is timing the blows correctly. They wait until the steel sits flush, then tack it in place. Then they heat the right side and return to the left side again. It looks slow, but this step is critical. Just 3 reinforcement bars can take half an hour. Besides the rail-like reinforcement pieces, there is also the main beam. The base is reinforced with high-grade steel. The length is measured almost to the millimeter. One thing stands out here. Instead of using the same steel everywhere, the crew switches materials in key areas. Once both sides are positioned, the center is struck with a heavy hammer. With only a few hard strikes, the straight steel bends into shape. 2 steel cylinders are welded onto the sides. The bracket opening is tightened. Without adding more steel there, that area is left hollow. The farther back it sits, the less wear it takes. The traditional bucket mount is not strong enough for this build. So the shop adds sections of leaf spring steel. Leaf springs come from truck suspension systems. They are extremely hard, and they handle pressure well. With the front, back, and sides reinforced, the bottom of the bucket cannot be ignored. Round bars are pressed into place and layered one after another. It is worth noting that ordinary plate steel is not used everywhere. Near the center contact area, cut tool steel is added instead. This is most likely for wear resistance when the bucket digs and curls back. This area takes the most abrasion. In rocky ground, that wear becomes even worse. The bucket is lifted again for the final finishing stage. All the earlier tack welds are now fully welded into place. The result is easy to see. Every corner has more than 1 layer. Some areas have been welded several times. For places the angle grinder cannot reach, smaller tools are used instead. The dark weld slag is ground away cleanly. The lugs on the linkage bracket receive extra welding passes. Some are welded 5 times. The surface is polished until it reflects light. Once the grinding is finished, the teeth can finally be installed. For the teeth, the crew uses original Volvo parts. They are chosen for strength and durability. The installation is straightforward. First, the tooth slides onto the adapter. The hole inside the adapter lines up with the retaining pin. That center opening allows the pin to slide in cleanly. Whether the parts come from Volvo or Caterpillar, wear is unavoidable in real work. The difference is how long they last. So how is this heavy-duty bucket installed? And how is it different? Now the work moves outside. Here's the field installation footage. The worker in the white hard hat first inserts 2 small shafts through the holes. Then he finds a bolt and nut and pushes them through. Once both sides are tightened, the excavator arm and hydraulic system allow the operator to lock it in without leaving the cab. If you time the movement, it takes only about 10 seconds. The only issue is the loose movement, because the bushings are not installed yet. That means during digging, it may not move as smoothly as expected.